NEC 334.80 states that the ampacity of non-metallic sheath cable, or NM cable, shall be based on the 60°C temperature rating of the conductor. This requirement is enforced by electrical inspectors. Inspections passing and failing can be due to different interpretations or applications of the code by the respective inspectors. According to NEC 334.80, number 6 NMCU cable has an ampacity of 55 amps at 60°C. Therefore, using it for a 60 amp load is a code violation. The use of a 60 amp breaker is also a code violation because the breaker should be sized to protect the conductor, which in this case is only rated for 55 amps. Electrical inspectors are required to enforce NEC 334.80, which prohibits the use of number 6 NMCU cable for 60 amp loads. Any inspections that allow such installations are not in compliance with the code. To elaborate further, the National Electrical Code, or NEC, sets the standard for safe electrical installations. It's a comprehensive document, updated every 3 years, that aims to protect people and property from electrical hazards. One critical aspect of the NEC is ensuring that electrical conductors, like wires and cables, are used within the rated ampacity. Ampacity is the current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. This temperature rating is crucial because excessive heat can damage the insulation of the conductor, leading to shorts, fires, and other dangerous situations. Non-metallic sheath cable, or NN cable, is a common type of electrical wiring used in residential buildings. It consists of 2 or more insulated conductors wrapped in a non-metallic outer jacket. NM cable is typically used for branch circuits, which supply power to lights, receptacles, and appliances. NEC 334.80 specifically addresses the ampacity of NM cable. It mandates that the ampacity of NM cable must be determined based on the 60°C temperature rating of the conductor insulation. This is a conservative approach that ensures the cable operates safely under typical conditions. The reason for using the 60°C rating is due to the potential for heat buildup within the cable bundle, especially when multiple NM cables are run together through insulated walls or ceilings. The 60°C rating accounts for this potential heat buildup and provides a safety margin. Now let's consider the specific example of number 6 NMCU cable. This refers to a copper conductor with a size of number 6 American wire gauge, or AUG, insulated and sheathed in a non-metallic jacket. According to the NEC, number 6 NMCU cable has an ampacity of 55 amps when rated at 60°C. This means that this cable can safely carry up to 55 amps of continuous current without exceeding its temperature rating. The question raised concerns the use of number 6 NMCU cable for a 60 amp hot tub circuit. As we've established, number 6 NMCU cable is only rated for 55 amps at 60°C. Therefore, using it for a 60 amp load is a clear violation of NEC 334.80. The reason this is a code violation is because the cable is being subjected to current higher than its safe carrying capacity. This can lead to overheating of the conductor, degradation of the insulation, and potentially a fire hazard. The fact that some inspections may have passed such installations does not make it compliant with the code. It simply indicates a lack of proper enforcement or a misunderstanding of the code requirements on the part of the inspector. In addition to the cable ampacity, the breaker size is also a critical factor in electrical safety. A circuit breaker is a protective device designed to interrupt the flow of current in a circuit when an overload or short circuit occurs. The breaker is sized to protect the conductor from overheating and potential damage. The NEC requires that the breaker size be matched to the ampacity of the conductor it is protecting. In the case of the 60 amp hot tub circuit wired with number 6 NMCU cable, the use of a 60 amp breaker is also a code violation. Since the number 6 NMCU cable is only rated for 55 amps, the breaker should not exceed 55 amps. Using a 60 amp breaker would allow the cable to be overloaded beyond its safe carrying capacity, increasing the risk of overheating and fire. The correct approach would be to use a conductor with a higher ampacity that is suitable for the 60 amp load, such as number 4 an MCU cable, which has an ampacity of 70 amps at 60 degrees Celsius. Alternatively, the load could be reduced to 55 amps or less to match the ampacity of the number 6 NMCU cable. It's also important to consider the specific installation conditions when determining the appropriate conductor size and breaker size. Factors such as ambient temperature, the number of conductors in a raceway or cable bundle, and the type of insulation can all affect the ampacity of a conductor. The NEC provides tables and guidelines for adjusting the ampacity of conductors based on these factors. Electrical inspectors play a crucial role in ensuring compliance with the NEC. They are responsible for reviewing electrical plans, inspecting electrical installations, and enforcing the code requirements. When an inspector finds a violation of the NEC, they have the authority to require the contractor to correct the issue before the installation can be approved. In the case of the 60 amp hot tub circuit wired with number 6 an MCU cable, an inspector should immediately identify this as a code violation and require the contractor to replace the cable with a properly sized conductor and reduce the breaker size to match the conductor ampacity. It's important to note that the NEC is a minimum standard. Some jurisdictions may have additional requirements or amendments to the NEC that are more stringent. It's always best to consult with a qualified electrical contractor or the local building department to ensure that your electrical installations are in compliance with all applicable codes and regulations. Understanding and adhering to the NEC is essential for ensuring the safety and reliability of electrical systems. By following the code requirements, we can minimize the risk of electrical hazards and protect people and property from harm. In summary, NEC 334.80 clearly states that the ampacity of an cable must be based on the 60 degrees Celsius temperature rating of the conductor. Using number 6 an MCU cable for 60 amp load is a violation of this code. The breaker size must also be matched to the ampacity of the conductor. Electrical inspectors are responsible for enforcing these requirements to ensure electrical safety. Always consult with a qualified electrical professional to ensure compliance with all applicable codes and regulations. To further clarify the importance of adhering to the 60 degrees Celsius ampacity rating for an cable as stipulated in NEC 334.80, let's delve into the potential consequences of disregarding this requirement and the factors that contribute to the necessity of this safety measure. Firstly, overheating is the primary concern when an cable is used beyond its rated ampacity. When a conductor carries more current than it is designed for, it generates heat due to the electrical resistance of the wire. This heat can accumulate within the cable, especially when multiple cables are bundled together or run through insulated walls or ceilings. The 60 degrees Celsius rating is intended to limit the operating temperature of the cable to a level that will not damage the insulation or create a fire hazard. If the cable is allowed to overheat, the insulation can begin to break down, becoming brittle and cracked. This degradation of the insulation can lead to short circuits, ground faults, and ultimately, electrical fires. Secondly, the environment in which an cable is installed plays a significant role in its temperature rating. In residential buildings, an cable is often run through walls, ceilings, and floors that are insulated. This insulation can trap heat and prevent it from dissipating, further increasing the temperature of the cable. The 60 degrees Celsius rating accounts for this potential heat buildup in insulated environments. In contrast, if an cable is installed in a location where it is exposed to free air, the heat can dissipate more easily and the cable may be able to handle a higher current. However, NEC 334.80 specifically mandates the 60 degrees Celsius rating for an cable regardless of the installation environment, providing a consistent and conservative safety margin. Thirdly, the type of insulation used in an cable also affects its temperature rating. Different types of insulation materials have different temperature ratings. Some types of insulation are more resistant to heat than others. The NEC specifies the types of insulation that are permitted for use in an cable, and these insulation types are typically rated for 60 degrees Celsius or higher. However, even if the insulation is rated for a higher temperature, NEC 334.80 still requires that the ampacity of the cable be based on the 60 degrees Celsius rating, ensuring a consistent level of safety. Fourthly, the number of conductors within an NM cable also influences its ampacity. NM cable typically contains 2 or 3 current-carrying conductors, plus a grounding conductor. When multiple current-carrying conductors are bundled together in a cable, the heat generated by each conductor can affect the temperature of the other conductors. The 60 degrees Celsius rating accounts for this mutual heating effect. The NEC provides adjustment factors that must be applied to the ampacity of conductors when multiple conductors are bundled together in a raceway or cable. These adjustment factors further reduce the allowable current to prevent overheating. Fifthly, the quality of the electrical connections is also crucial for preventing overheating. Loose or corroded connections can create resistance, which generates heat. This heat can damage the insulation of the conductors and potentially cause a fire. It is essential to ensure that all electrical connections are properly made and tightened to prevent overheating. Electrical inspectors typically check the quality of electrical connections during inspections. Sixthly, the age of the NM cable can also affect its ampacity. Over time, the insulation of NM cable can degrade due to heat, moisture, and other environmental factors. This degradation can reduce the ampacity of the cable and increase the risk of overheating. It is important to periodically inspect NM cable for signs of damage or degradation and replace it if necessary. Seventhly, the presence of harmonics in the electrical system can also contribute to overheating of NM cable. Harmonics are distorted waveforms that can cause increased current flow in conductors, even when a load is not increased. These harmonic currents can generate additional heat in the cable, potentially exceeding its temperature rating. It is important to address harmonic issues in electrical systems to prevent overheating of conductors and equipment. In addition to the technical factors discussed above, it is also important to consider the legal and liability implications of violating the NEC. Electrical contractors who violate the NEC can be subject to fines, penalties, and even legal action. If an electrical fire or other incident occurs as a result of a code violation, the contractor may be held liable for damages. It is therefore essential for electrical contractors to be familiar with the NEC and to ensure that their work is in compliance with all applicable codes and regulations. The NEC is a complex and comprehensive document, and it is not always easy to understand or interpret. Electrical contractors should seek training and education to stay up to date on the latest code requirements. They should also consult with electrical inspectors and other qualified professionals when they have questions about the code. The goal of the NEC is to protect people and property from electrical hazards. By following the code requirements, we can minimize the risk of electrical fires, shocks, and other dangerous situations. It is the responsibility of everyone involved in the electrical industry to ensure that electrical installations are safe and in compliance with the NEC. In conclusion, the 60 degrees Celsius ampacity rating for NM cable as mandated by NEC 334.80 is a critical safety measure that must be strictly adhered to. Disregarding this requirement can lead to overheating, insulation damage, and potentially electrical fires. The factors discussed above, including the environment, insulation type, number of conductors, connection quality, cable age, and harmonics, all contribute to the necessity of this safety measure. By understanding and following the NEC requirements, we can ensure the safety and reliability of electrical systems and protect people and property from harm.